And here we go. Our objective today is to solve for missing sides of a triangle and to also solve triangles completely. So, look at this first example. We have a side of 9 and a side of x that we would like to find. We have an angle of 42 degrees. Opposite, adjacent, and hypotenuse. Which side is this right here? Hypotenuse. Which side is here? And that makes this the adjacent side. So this is the question that came up on Friday, or I'm sorry, Thursday, that people have to focus on. In this situation, you are given the opposite. You are looking for the hypotenuse. So this is going to tell you whether or not you use sine, cosine, or tangent. If I'm given opposite and hypotenuse to work with, do I choose sine, cosine, or tangent? Why? Opposite and hypotenuse are sitting right there. So therefore, I choose to use sine. And so we write this expression. Sine of 42 degrees is equal to what over what? The opposite, which is 9, divided by the hypotenuse, which is x. It's written as I'm going to write it over 1, so I have a fraction equal to a fraction, and I'm going to cross multiply and solve. I first have to find the sine of 42 degrees. I turn on my calculator. I go into mode to make sure I'm working in degrees. I press sine of 42 degrees. 0.6691. So 0.6691 over 1 is equal to 9 over x. How would you solve? Going to cross multiply. 1 times 9 is 9 is equal to 0.6691 x. So 9 divided by 0.6691, and actually, if you want, you can press second, the negative sign, answer, just takes that answer and plugs it right in there. And I get 13.45. Does it make sense that this side should be longer than the other one? Why? Since it's the hypotenuse, it should be the longest side of the triangle. Agreed? Try the next one. Opposite, adjacent, or hypotenuse? Adjacent. And this is the hypotenuse. If I'm working with adjacent and hypotenuse, do you use sine, cosine, or tangent? You use cosine. As you notice, cosine says adjacent and hypotenuse. I'll choose the cosine of 63 degrees is equal to what over what? Josh, is it 14 over x or x over 14? How come? Yep, adjacent hypotenuse, x over 14. I always write that over 1, and I cross multiply. X times 1 is x. And then I have the cosine of 63 times 14. I want to show you something you have to be very careful of. Don't go cosine of 63 times 14, because now it's taking the 63 and multiplying by the 14 first. So make sure that you either close your parenthesis or you write 14 times the cosine of 63. If you like to convert the cosine of 63 into a decimal first, you can, but we get 6.36. And that should be smaller than the 14. Opposite, adjacent, or hypotenuse? If I look at the angle and I go across, I find x, so that would be, in this case, the opposite. Looks like this one is the hypotenuse, so this one over here is adjacent. So it looks like I'm given the adjacent, I'm finding the opposite. Sine, cosine, or tangent? Tangent. Tangent of 27 degrees is equal to x over 9.4. I will cross multiply. X times 1 is x. And then I will take 9.4 times the tangent of 27. I get 4.79. That was an example of how to use all three of those trigonometric functions. Please take out your worksheet. We're going to do a couple of those problems on your worksheet together. Okay, problems 1 through 6, problem 1 through 6, those are exactly like what we just did. Okay, we're going to leave you to those, but if you flip it over to this side, we're going to do these two examples together. So we're going to solve the entire triangle in this situation. Please make sure you put your 90-degree angle in place. After that, you can label the triangle A, B, and C. I'm going to put A here, B here, and C here. This is important. Please make sure that you use the capital letters for the angles and the small letters for the sides. Angle C always goes with the right angle. Your goal is to be able to fill out all these unknowns right here. So angle C is 90 degrees. Angle B is 32 degrees. Again, the capital letters are the angles, the small letters are the sides. It is very important that you put the sides in the right spot. Side C goes across from angle C. Side A goes across from angle A. And side B goes across from angle B. Now, which one of these sides do you know? Yep, C is 8. So I'm going to take that C value right here. I'm going to write 8. You also know that angle B is 32 degrees. So this is just slightly different than what we started out with. In this situation, you can actually have a choice whether you're going to use sine, cosine, or tangent, but it starts with you making a decision first. Okay? So, Caitlin, you get to choose, and it doesn't matter which one you choose. Would you like to find side A, or would you like to find side B? She wants to find side A. Xavier could have said, I want to find side B. It doesn't matter. You make the choice. Everybody got it? All right. So she's going to find side A right here. That's what she wants to work with. Is that the opposite, the adjacent, or the hypotenuse? It's the adjacent. It's next to the 32-degree angle. She is given side 8. Is that the opposite, adjacent, or hypotenuse? Hypotenuse. So notice in this situation, she's looking for the adjacent, and she's finding the hypotenuse. Xavier, if he chose to find side B, he would be using the opposite and the hypotenuse. Okay? So Caitlin is using the adjacent and the hypotenuse. SOHCAHTOA. Adjacent and hypotenuse, sine, cosine, or tangent. Cosine. So the cosine of 32 degrees is equal to adjacent, which is A, divided by hypotenuse, which is 8. I cross multiply. A times 1 is A, and I have 8 times the cosine of 32. $6.78. That's the difficult part. The rest is easy. Does anybody know how I can find angle A? I know the other two angles of the triangle. They all must add up to 180. So I take 180 and I subtract 90. And I subtract 32. And I get 58 degrees. My angles are all solved for. Suppose that you would like to find side B. You know two other sides of the triangle. What can you use if you're working with a right triangle and you have two sides? Pythagorean theorem. A squared plus B squared is C squared. So we have 6.78 squared plus B squared is equal to C squared, which is 8 squared. That's what I'm going to use to solve B. 6.78 squared, 4597. Plus B squared is 64. I subtract 64 minus 45.97. I get 1803. B squared is equal to 18.03. And then I square root 18.03. 4.25. When you are solving a right triangle on the test, here's one way you could check your answer. The biggest angle should be matching with the biggest side. The smallest angle should match with the smallest side. And the middle angle should match with the middle side. If I had angle C was 90, but the side was 3, I know that would be wrong. Biggest angle must be across from the biggest side. These two will follow just like that. We do one more example, and then you guys are going to have time to work here. 90 degrees, we'll call this angle C. You can choose whichever one you want to be A or B. C must be the 90-degree angle, but if you want this to be A, you can, or if you want this to be A, you can. That one's up to you. What I'm going to do, though, is I'm going to see that A is the shorter side. So I'm going to choose A to be this short side here, so angle A is going to be over there. If you chose differently, it would be okay. It's just that the triangle wouldn't look right, which is okay. So I've got angle B there. Okay, you help me out. Where should I start? What do I know? Okay, so A is 5 and B is 12. What makes this problem different than the previous problem? Yeah, we don't have an angle, do we? We just have the 90-degree one, that's it. So what's going to be the easiest thing to solve for? Angles A and B or side C? Side C, again, we can use the Pythagorean theorem. 5 squared plus 12 squared is equal to C squared. 25 plus 144 is equal to C squared. 169 is C squared, so C is 13. Now, here's where you need to make a choice. Aiden, would you like to find angle A or would you like to find angle B? You get to choose. He wants to find angle B. This is very important you make a choice because that changes which side is the opposite, the adjacent, or the hypotenuse. Obviously, angle C is the hypotenuse, but if he wants to find angle B, then is 12 the opposite or the adjacent? It's the opposite. And 5 is the adjacent. This is extremely important that everybody understands this point right now. If he were to choose A, he wants to solve for A, then this would be the opposite, wouldn't it? And that would be the adjacent. So you have to choose which angle you're working with. He has all three sides. So now he gets to make a choice. Aiden, do you want to use sine, cosine, or tangent? He's going to use tangent. So he sets up tangent of angle B is equal to, and tangent is going to be what over what? Opposite over adjacent. So opposite over adjacent, 12 over 5. Do you remember from Thursday what we do in order to find an angle? So this is different because I don't have the angle. What do we press? Yep, good. Second tangent. And then you type in the 12 divided by 5, and that's going to come up with an angle for you. I get 67/38. Great. Angle B is 67/38. So how do I find angle A? All three angles must add to 180. So 180 minus 90 minus 67.38. 22.62. That's the last piece of content that we have to learn before we have our test. So we're going to spend the next couple of days reviewing. I have that ready to go. Please use your time wisely. You have about 22 minutes to be able to start working on solving these pieces. I expect that approximately half of the class is going to have a question at some point on what we're doing. It's okay to not completely know what's going on right now, but we have to start figuring it out. You got to start trying the problems. I'm going to get the answer key so you can check them right away. Here we go. I did this